Hi, thanks for joining. We're going to talk about our last function operation today. So grab your spiral notebook. Let's find a new blank page. Okay, don't start your notes after the end of the last examples. Always start on the beginning of a new page so it makes it easy to find. And we're going to label this function composition. Okay, this is going to be the last concept we learn in this unit before we take our quiz. So we're going to start with some definitions. Function composition is a new operation that's going to have a new symbol. And so what it's going to look like is this. And it's said f of g of x. And you're looking at it and you're probably thinking you just see the word fug, okay? If this was a closed circle, then that would be multiplication, but the open circle indicates this new operation called composition. So you're going to see this commonly on papers or on tests or maybe even like an ACT test, this notation, but I prefer to change it using this definition, and what we're going to do is rewrite it like this. We're going to leave the order the same. We're going to have the f function come first, but instead of an open circle, I'm going to use parentheses. And then on the inner, we're going to have g of x. So in fact, now that I write this, the notation on the right should look familiar. And we have actually been doing function composition since your very first homework assignment when I nested one function inside of the other. So hopefully this won't be too confusing today because really you've been doing it. Now you've been doing it with a number. We're going to today learn how to do it with a variable. All right, now let's change the order here. And what we're going to see in our first example is by changing the order of the composition, does that change the answer? So the way that we would write this is as g with f of x kind of nested on the inside. All right, so those are going to be the definitions that I use in every single problem that we set up for today. Let's look at a few examples. All right, example 1, we're going to pretty much just use these functions the entire time. So we've got f of x is 2x minus 7, and we've got g of x, which is going to be x squared plus 4. And I'm going to work through probably about 4 different examples, but we're going to use these two given for the entire time. All right, part A. I want to find f of g of f of 3. Okay? So first thing again is when we have this notation with the open circles, the first thing that I want you to do is use the definition to replace all your open circles with parentheses. I like this notation better because it does a better job of showing me what we're going to do first. And what we're going to do first is we're always going to start with the innermost function. So I'm going to come over here and I'm going to figure out what f of 3 is equal to. Well, f of 3, if the rule is 2x minus 7, then that means that we're going to plug the 3 in for x, and we're going to perform this little operation. And I get negative 1. So this whole part right here, the f of 3, becomes a negative 1. And what I'm going to do is I'm going to bring down the g, and I'm going to bring down the f. Okay, and I'm just going to keep bringing stuff down. Now what I'm going to do second is now this is the inner function. So I'm going to come over here and I'm going to find g of negative 1. Well, the rule for g is x squared plus 4. So what we're going to do is replace the x with a negative 1. Negative 1 squared is negative 1 times negative 1, which becomes positive 1. And what I see here is I get 5. So this part is equal to 5, and I just need to finally bring the f down. And finally, I do f of 5. And so this is what I would do third. And third, I'm going to find what f of 5 is. Well, the rule of f, again, is 2x minus 7. So let's input a 5 for the x, and we get 10 minus 7, and it's equal to 3. So finally, our answer is 3. So really, it's not that much different than what we were doing before. It's just that we start with the inner function, and then that answer gets plugged into the next function. And then that answer gets plugged into the next function, and on we go. Okay. Let's look at this as f of g of x. Now, first thing I want you to do on your paper is I want you to rewrite this using the definition, because this nested parentheses does a better job of telling us the order in which we're going to do the problem. So again, we start with this inner function, so I'm going to leave the f, but I'm going to replace g of x with the given rule, which is x squared plus 4. So I'm going to take out the g of x, and I'm going to replace it with what g of x equals, which is x squared plus 4. Well, now, once I do that, we've been doing this kind of since the beginning of the unit. So here's what the rule for f looks like. It's 2x minus 7. What we're going to do is replace the x with x squared plus 4 and minus 7. So we're going into f, and we're replacing the x with this input x squared plus 4. And then we just simplify. I'm going to distribute the 2, and we're going to take 8 minus 7, which is 1. And so what we've done here is made a new function that has the g of x function plugged into the f function. Let's try something like that again, okay? And the nice thing about these videos too is, like we talked about, regardless of how well you understand it, you're still responsible for writing the information down. So if you think you've got the hang of it, why don't you hit pause, work the problem out, and then kind of go to the part where I get the answer and see if you did it right. All right? If it's still a little confusing, hit pause if you need to, so you've got time to write stuff down if I'm going too fast. All right, so now we're going to reverse the order g of f of x and see if it changes our answer at all. So first thing I want you to do is I want you to use the definition to rewrite it as g of f of x with nested parentheses. I've been doing function composition for a long time, and I always, in my first step, rewrite using the definition. Now, what is the f of x function? What was that equal to? Remember, f of x was given as being 2x minus 7. So we're going to replace f of x with its rule or its equation. Okay, so now we're going to go into the g function. Here's what the g function is. It's x squared plus 4. And we're going to replace the x with the input 2x minus 7. So we just plugged the f function into the g function. And now we remember that anything squared means we times it by itself twice. And before we add 4, we're going to need to do a little double distributing here. So I'm going to start by taking 2x times 2x. I'm going to scooch this up a little, and we're going to get 4x squared. We're going to take 2x times negative 7 and get minus 14x. Then we're going to distribute the negative 7 and get minus 14x again. And we're going to take negative 7 times negative 7 and get plus 49. And then don't forget about adding on your 4 at the end. So if we combine like terms, I have different like terms. I've got my negative 14x and my negative 14x. And then I can also see that I have this 49 and this 4. So let's combine like terms. 4x squared, negative 14 and negative 14 make negative 28x, and 49 plus 4 is going to give me 53. Okay? And so that is my new function that has the f function plugged into g. And you can see that it does change the outcome of the answer by switching the order. Okay? We are going to try for part C, we're going to try g of f of a plus 3. Okay. First thing I want you to do, let's rewrite this with our nested parentheses using the definition. Okay, this means g of f of a plus 3. And this is what I'm going to do first. So I'm going to come over here, and for me to find f of a plus 3, I'm going to take my f function and I'm going to replace the x with an a plus 3. And then we're going to distribute the 2, right, minus 7. And I'm going to keep simplifying. So this is what f of a plus 3 equals, 2a minus 1. So this f of a plus 3 can be replaced with 2a minus 1. And I'm going to bring down my g. Now, let's go into the g function, which is x squared plus 4, and I'm going to replace the x with 2a minus 1. Always take that part that's in the parenthesis, the input, and replace the x with it. And so again, we're going to have to multiply 2a minus 1 and 2a minus 1, and we're going to double distribute that again. And then finally, we'll add 4. So let's go through. Maybe if you kind of feel like you know what you're doing from here, this would be a good time to hit pause and continue the problem and then kind of fast forward to the end, or keep following me step by step. 2a times negative 1 gives me negative 2a. Take negative 1 times 2a, and then finally I get negative 1 times negative 1, which gives me plus 1. And don't forget to bring down your plus 4. So what like terms do we see? I see a negative 2a and a negative 2a. I see a plus 1 and a plus 4. So let's simplify. 4a squared minus 4a, and then 1 plus 4 is going to give me 5. Okay, so that's getting a little fancy there, but we can do a little bit of composition where we plug something into our first function and take that and plug it into our second function. So if you want to try one on your own, here's what I would suggest. On your own, I want you to try f of x. Okay? Good luck with that. We'll come back to class. You can ask questions. We'll definitely work on this more, and we'll see you next time. Thank you. Bye.